Chapter 3 Matrices, Class Number 1. A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries of the matrix. The following are some of the examples of matrices. Horizontal lines of elements constitute the rows of a matrix, while the vertical lines of elements constitute the columns. For example, A has 3 rows and 2 columns. Concept order of a matrix. A matrix having m rows and n columns is called a matrix of order m by n, referring to the examples in the previous slide. A is a 3 by 2 matrix. B is a 3 by 3 matrix. A has 6 elements, whereas B has 9 elements. In general, a m by n matrix has a rectangular array as displayed in the slide. In the general form of representation of a matrix, the ith row consists of elements ai1, ai2, all the way up to ain. The jth column consists of the elements a1j, a2j, a3j, all the way up to amj. In general, Aij is an element lying in the ith row and jth column. The number of elements in am by n matrix is mn. A quadrilateral ABCD with coordinates given in the slide can be either represented as X, which is a 2 by 4 matrix, or by Y, which is a 4 by 2 matrix. If a matrix has 8 elements, what are the possible orders it can have? We know that if a matrix is of order m by n, it has mn elements. To find all possible orders of a matrix with 8 elements, we need to find all ordered pairs of natural numbers whose product is 8. Possible pairs will be 1, 8, 8, 1, 2, 4, 4, 2. Sum number 1. Construct a 3 by 2 matrix whose elements are given by aij is equal to half of mod I minus 3j. A general form of 3 by 2 matrix can be written as A is equal to A11, A12, A21, A22, A31, A32. Now, as given in the problem statement, Aij is equal to half of mod I minus 3j. I takes values 1, 2, 3. J takes values 1 and 2. This is based on the general form of 3 by 2 matrix as mentioned above. We replace the value of I and j in the generalized form of 3 by 2 matrix, and the elements of the matrix is computed as shown. Hence, the required matrix A will be a matrix is said to be a column matrix if it has only one column. For example, A is a column matrix of order 4 by 1. Similarly, a matrix is said to be a row matrix if it has only one row. For example, B is a row matrix of order 1 by 4. Concept square matrix. A matrix in which the number of rows are equal to number of columns is said to be a square matrix. A m by n matrix is said to be a square matrix if m is equal to n. A square matrix is said to be a diagonal matrix if all its non diagonal elements are zero. Consider a matrix named capital B. Any element of this matrix can be represented by small bij. If bij is equal to 0, then this matrix is a square matrix. The non diagonal elements which can be represented by bii are non zero. Examples of square matrices are shown in the slide. Concept: Scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Consider a square matrix B. B is said to be a scalar matrix if Bij is equal to 0 when I is not equal to j. Bij is equal to, say, an integer k when I equals j. For example, in a 3 by 3 matrix, B11, B22, B33 are equal and rest of the elements are 0 in a scalar matrix. Examples of scalar matrices of order 1, 2, and 3 respectively. Concept: Identity matrix. A square matrix in which elements of the diagonal are all 1 and rest of the elements are 0 is called an identity matrix. For a matrix capital A, in a square matrix, the element small aij will be equal to 1 when I equals j, will be equal to 0 when I is not equal to j. We denote the identity matrix of order n by In. In the slide, identity matrices of order 1, 2, and 3 respectively are mentioned. Concept: Equality of a matrix. Two matrices A and B are said to be equal if they are of the same order. Each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and j. Examples are given below. Zero matrix. A matrix is said to be a zero matrix or null matrix if all its elements are zero. Sum number 2. Find the values of a, b, c, x, y, and z with respect to the matrices given. As the given matrices are equal, the corresponding elements are also equal. Comparing the corresponding elements for the two matrices we get. Simplifying, we get A equals minus 2, B equals minus 7, C equals minus 1, X equals minus 3, Y equals minus 5, Z equals 2. In the matrix A, whose elements are given in the slide, find the order of the matrix, total number of elements in A, and the elements of the sets as asked in the problem statement. The order of the matrix will be 3 by 4 as there are 3 rows and 4 columns. Number of elements in the matrix A is 12. The elements of the matrix required in the problem statement are given as below. Sum number 4. If a matrix has 24 elements, what are the possible orders it can have? What if the matrix has 13 elements? Now 24 can be written as 8 different ways where m multiplied by n is 24, m and n both being integers. There are 8 possible matrices having 24 elements. The possible orders of those matrices are mentioned in the slide. For the second part of the question, 13 is a prime number and has just two factors. Hence, only two possible matrices can be constructed with 13 elements of orders 1 by 13 and 13 by 1 respectively. Sum number 5. Construct a 2 by 2 matrix A whose elements are given by Aij equals I plus j whole square by 2, Aij equals I by j, and Aij equals I plus 2 j whole square by 2. Sum number 6. Constitute a 3 by 4 matrix whose elements are given by Aij equals half of mod minus 3i plus j, and Aij equals 2i minus j. The number of all possible matrices of order 3 by 3 with each entry either 0 or 1 is 27, 18, 81, or 512. We first write the generic form of a 3 by 3 matrix, which has 9 elements in total. The number of possible choices for each of the elements in the matrix, that is starting from A11 to A33, is 2, because the element can be either 0 or 1. Total number of possible choices will be 2 to the power 9 or 512. Option D is correct. End of class number 1 on matrices.